Morning. So last time we started with chapter 5, which talks about analog transmission. And as we said in chapter 3, we discussed the advantage and disadvantage of digital transmission over low pass channel and analog transmission over band pass channel. And in chapter 4, we studied digital transmission. Chapter 5, we focus on analog transmission. And for analog transmission, we have two main steps: digital to analog conversion to convert digital data into band-pass analog signal, then analog to analog conversion to convert a low-pass analog signal to high-frequency or band-pass analog signal. And we started by the first part, which is digital to analog convergence. And we said that we have three main techniques, or four main techniques that can be used for digital to analog convergence. And these the main three techniques deals with how we can change the characteristics of an analog signal based on received digital data. So we can change the amplitude through amplitude shift key, or change the frequency using the frequency shift key, or changing the phase using the phase shift key, or combination between the amplitude and the phase and change both the amplitude and the phase using the QAM modulation. Okay, and we started by binary amplitude shift key, and we said that the bandwidth for this binary amplitude shift key is 1 plus d multiplied by s, where s is the signal rate. And in the binary amplitude shift key, we change the amplitude based on the received data. So L1 give amplitude مثلا equal to V, and 0 will have 0 amplitude. So we name it on-off keying or amplitude shift keying. And the implementation of this technique is very easy, just using unipolar non-return to 0 to represent the digital data, then multiply by the signal we want to change the amplitude for with carrier frequency Fc, and in this case the bandwidth will be 1 plus d multiplied by s. Okay, and we discussed the main disadvantage of this technique, which is the amplitude, changing the amplitude, so it will be very sensitive to the impairments of the channel. Okay, and we said that we can using full duplex communication. In this case, we will transmit the transmitter data on frequency FC1, and the receiving will be on another frequency, on another central frequency FC2. In this case, we can implement a full duplex link communication. Then we discussed the binary frequency shift key. In this binary frequency shift key, we change the frequency based on the received data. So L1 can take frequency F1 and 0 can take frequency F2, and in this case the bandwidth will be 1 plus D multiplied by S plus 2 delta F, where 2 delta F is the spacing in the frequency between F2 and F1. And within that, the minimum value of delta F can be S when D equal to 0. Okay. And the implementation of a binary frequency shift key was using a unipolar non-return to 0, and then multiply by signal coming from a voltage control oscillator, and in this case we'll have coherent binary FSK, or deal with this binary FSK as a two separate amplitude shift modulation with two carrier frequency, with two separate carrier frequency, and in this case we will have non-coherent binary FSK, and we may have disjoint in the phase. But in coherent FSK will have continuous phase. Okay, and we stopped on these examples. The general case of a multi-level FSK, if we need to send multiple data or multiple bits at the same time, so we need to increase the R. So in this case, we'll increase the number of levels because we will have many combinations. For example, if I have 3 bits need to send at the same time, we'll have 8 combinations. So we should have 8 levels. So 8 level should be represented by 8 frequency if we will use the multi-level FSK. In this case, the general formula for bandwidth will be 1 plus D multiplied by S plus L minus 1 2 delta F, because we need to account for the spacing between every two frequencies. And if d equal to 0, so the best bandwidth will be L multiplied by S direct. And we said this example. In this example, uh, did you notice any error or anything؟ يا ما حدش ذاكر. Here we say that we need to send 3 bits at a time. So 3 bits, it means that LR equal to what? We send 3 bits at the same time. So 3 bits represented in one signal. So LR will equal to 3 because I need to send 3 bits. So and the L will be 2 to the power m. M is number of bits I need to send. So it will be 8. Right. At the time at a bit rate 3 megabit per second. So the bit rate n equal 3 megabit per second. So what will be S divided by 3? S equal to n over R. So it will 1 mega, not 1000. Yeah, it's written 1000. And example direct from the book as a typo. That should be 1 mega boot type. If the carrier frequency is 10 megahertz, calculate number of levels and boot rate and the bandwidth. The bandwidth here we will have minimum bandwidth, so if d equal to 0, so bandwidth will be L multiplied by S, so it will be 8 megahertz. This boot, okay? So not 8000, it will be 8 meg. And this is correct in the figure. Bandwidth will be 8 mega. Central carrier frequency will be at 10 megahertz. For the different 8 levels. Okay? Any questions? Hmm. Okay. So now we'll move to a binary phase shift key. So in the amplitude we change the amplitude, in the frequency we change the frequency. Now in the binary phase shift key we will change the phase of the signal based on the received data. So we'll have the same carrier frequency, but we represent different signal elements by different phase. So for example, L1 will have phase 0, so it will start from 0, and the 0 will have phase equal to yeah, مش مهندس 180 على طول. Okay, and if I start from here is 0, here is 90, here is 180, by 270. Okay, okay. So in this case, what will be the bandwidth? Will be the same as the amplitude shift key because each bit will represented by one signal element and we have same frequency. So R equal to 1, S equal to N, and bandwidth will be 1 plus D multiplied by S, and we have one carrier frequency FC because we change the phase. Okay, so bandwidth will be the same as the amplitude key. So what about the advantage of this binary phase shift key؟ يعني الباندويث same as the amplitude shift key. طب what about بقى الادفانتج؟ يعني احنا قلنا الامبليتيود شيفت كي كان ديس ادفانتج بتاعته الامبيرمنت والنويز. ف we move to the frequency shift key. Frequency shift key كانت مشكلته ايه؟ What the problem in the, what the disadvantage in frequency shift key؟ Mm. And large bandwidths because I use two frequencies, so I consume more bandwidths. Now, in phase shift key, what's the advantage? What are the advantages of phase shift key? Does it solve the problem of amplitude shift key? Is it sensitive to the environment? No, because the phase is less sensitive to the environment than the amplitude. And a different environment can be noise, attenuation, and distortion. And all these three factors affect significantly the amplitude, not the phase. So the phase is less sensitive to the errors of the channels. So it will have less bit error rate in the channel because we change the phase, not the amplitude. Right. Does it solve the problem of binary TCP, which is large bandwidth? Yes. Yes, because we still have 1 plus ds, so we return to the same method of the amplitude key. So binary shift key solves the two problems in the amplitude shift key and the frequency shift key and takes the advantage from both. Take advantage of the frequency shift key because it's less sensitive or less sensitive to the noise, so it's better than the amplitude shift key. And at the same time, it's better than the FSK because we don't need two carrier frequency. We need only one carrier frequency, so the bandwidth is less than the phase shift key. Okay, it's important to know the differences between different techniques and the comparisons between different techniques. And this is the main, يعني, the main issue that will be asked in the midterm or quizzes. Is how is to know the difference between different techniques. So noise change amplitude significantly. So this was the problem in amplitude shift key. And in bandwidth was the problem of SSK. Now phase shift key solves these two problems. It's less sensitive to the noise and it doesn't need more bandwidth. Okay? Okay. So what's bad disadvantage؟ يعني هو has only advantage ولا عنده disadvantage؟ Hmm. It solves the problems of amplitude shift key plus frequency shift key. But does it add new problem or new challenge? Hmm. From an implementation point of view, is it easy to change the amplitude or a phase? Amplitude. So the amplitude is less complex from the implementation or hardware point of view. But changing the phase is a little bit challenging from a hardware point of view. Also from a decoding point of view, because the receiver should detect the actual phase and should know if it's zero, for example, or 180 or something. So also to detect the phase is more difficult than just to put threshold at the amplitude, and if it's above third threshold it will be one, below third threshold it will be zero. And if you need to program مثلا something like this to decode the amplitude key is very simple. You will put threshold above it will on, below it's zero or something. But in phase you will need more يعني complex hardware and more complex receiver to encode and decode this modulation. So the main disadvantage is complexity. Yes, it's complexity. Okay. Right. What about the implementation? How we can implement that, like we did in amplification frequency key? In this case, the implementation will be similar to the amplitude shift key, but in this case we'll use we'll use polar non-return to zero because now I need a positive voltage and negative voltage. So if I have one positive voltage, I will start the phase from zero. If I have zero, I have negative voltage, it means that I will invert the phase to 180. So in this case, I will need polar non-return to zero to get the positive and negative feedback. Okay? So just polar not to zero and one oscillator because I need one. We have one frequency, one center frequency, one carrier frequency, and we just multiply the polar not to zero with the carrier signal coming from the oscillator. Okay, is it clear? It's important to know these figures, yeah, how we can implement this. The main difference is amplitude key is the same figure, but with because I need to change amplitude only. Key we use polar to make the phase 0 or 180. In frequency key we use two frequencies or voltage control oscillator. Okay, that is for this part. Until now we started amplitude key, frequency key, and phase shift key. Now we'll move to QAM. But before QAM, we have another case from الphase shift key. We studied the binary phase shift key. And we mean by binary phase shift key, we have 0 or 1. So 0 will be in phase, and phase 0, and with the same phase of the signal. And 1, we give it 180 phase, it means out of phase. We name it out of phase. Okay? So it will have 180. And we send one bit per signal. Now I need to increase the R. Instead of sending one bit, 0 or 1, I need to send two bits, 0, 0, 0, 1, 1, 0, 1, 1. So I need to send any two bits at the same time. Okay. So how many levels now? L equal 4. Okay. So how back can I represent these four levels with the phase? So I need four values for the phase. I need four phases by now. Here, in phase or out of phase, because I have 0 or 1. So I have two values for the phase. Now I have four different combinations. So L is equal to 4. So I should have four phases. Okay. So to send two bits at a time, we require more bandwidth. We require less bandwidth, sorry. And we use QBSK. QBSK, so it means that once I said for you QBSK, I will not give you R. If I said you use QBSK, I will not give you R. QBSK, but R equal to R. Okay. So in binary BSK, we used one in phase and one out of phase, or we name it quadrature. And now for QBSK, we use bit splitter and two multiplier with two oscillators. And I need four values for the frequency, and we have two bits. So as we said, each bit will have bit splitter, so we have 0, 0, and this will multiply by a certain frequency, and this multiply by a certain frequency, then we will sum to deal with these four. So in this case, I should have four phases. The four phases will be 45 minus 45, 135, and minus 135. These are the four phases that I will use to represent the different four levels in a QBSK. Okay? And in this case, we'll have L equal to 4 and R equal to 2. And this is how we can implement this. فركزوا معايا بقى. QBSK will have two bits. I will take, I will see one bit here and one bit here. This one bit will multiply directly by the oscillator. In this case, in phase. So phase equal to 0. And here I will multiply by the same signal but with phase shift 90. So this signal will multiply by phase shift 90 and this is multiplied by the phase direct, phase 0. Then what we'll have here will sum and send. So in this case, 2 bits enter, then 2 bits out. But how So now, to generate this, we divide the bits into two paths, and in the first pass we will multiply by the carrier signal in phase, and in second pass we'll multiply by carrier signal shifting by 90. Then we will submit the output to generate four different phases in this case. Four different phases representing four different combinations 00, 10, 01, 11. Any question? Hmm? So QBSK will have the main يعني to sum up QBSK are equal to we have four levels. We need four phases to represent this QBSK. So the implementation will be we have 2 to 1 converter to split bit splitter to split the bits. The first bit will multiply by the oscillator direct. The second bit will multiply by the carrier signal coming from the oscillator with shifting 90. Then we will sum. This is the main idea of QBSK. What about the bandwidth now? If we transmit, if for a signal transmitting 12 megabit per second for QBSK and d equal to 0, what will be the bandwidth? الباندوث كانت ايه؟ 1 plus d is d equal to 0 خلاص. طب الاس equal to n يعني 12 divided by r لانه كيو اس كي من غير ما تديكوا الار. فكيو اس كي يبقى الار equal to 2 يبقى الاس equal to 6 ميجا d equal to 0. فتيك care if it's cube is k, so in this case ls will be n over r, not n direct. Okay. طيب. Is it easy to imagine QBSK? Because QBSK have four levels. But what if we have L equal 16 level? We'll have 16 value for the phase. Is it easy to يعني deal with 16 value of the phase يعني to represent these values? And we may have يعني now in nowadays communication system we reach to L equal 256 كمان. Nowadays communication system. So to represent these levels and these phases we can't use يعني our imagination. We need this يعني simple representation of these multi levels of these multi phases techniques if we increase number of levels. So laser زي as we will be very complex to be represented in time with multiple frequencies. So we shifted to the phase to the frequency domain by just values or just يعني different frequencies. Now the same concept. We need to represent the multiple level and the multiple phases in high constellation modulations. So we use what we name it constellation diagram. What is constellation diagram? هو to understand this يعني المين الباينري فيش شيفت كي كان بيست على ايه؟ ان احنا we have in phase carrier and out of phase carrier. Carrier starts by 0 in phase and carrier starting from 180. فده البيزكس. We have in phase carrier and out of phase carrier or quadrature carrier. Okay? To represent بقى any combination or any level, we represent it by one point on this x-axis, y-axis. Okay? And near to this point, we wrote our value of combination or level. For example, here this example for L equal 4. The first point is 0 0. 0 0 كان الفيز بتاعها كام؟ From Q base K. لا from Q base K. لا كان 45. In Q base K. In Q base K كان عندنا 45. This 45. So if I need to draw now in Q base K, I will have in phase component and out of phase of quadratic component. And we have four values. الفيز كان كام؟ 45 135 و minus 135 third phase و minus 45. طب what about the amplitude? Do we change the amplitude? No. فكلهم same amplitude. فكده 0 0 0 1 1 0 1 1. طيب بياخدوا circle. So this is the representation for now if I need to represent 265 I have much easy. I will put 256 point. Each point will have certain amplitude and certain phase. So I can represent whatever number of levels or whatever modulation techniques using the IQ diagram or a constellation diagram. So in constellation diagram, we define the amplitude and phase of each signal element. And this signal element, point zero represent signal element. Signal element may carry certain bits or certain information. فالconstellation diagram we define amplitude and phase of each signal element. Okay? Which signal element will be represented by one dot or one point on this diagram. Will this combination carried in this signal element will be written near to this element. Each signal element will have certain amplitude and certain phase and will be represented by an IQ diagram or constellation diagram. Okay? The horizontal axis related to in phase carrier and the y-axis related to quadrature carrier. Okay? Is it clear how we can plot this diagram or how can draw this diagram for any type of modulation بقى. طيب let's take an example بقى. احنا لحد دلوقتي what we studied الامبليتيود شيفت كي الباينري phase shift key Q phase shift key والفريكونسي phase shift key. ده الاي كيو. اول how many points will have. لو قلنا binary points will binary. يعني one signal element represent one bit. When we have 0 1 يبقى we have in this case ال L equal to. طيب I need to load two bits. So we have phase 0 وامبليتيود 0 for the 0. per 1 كان phase 0 يعني I know بس امبليتيود كان certain amplitude سواء 1 او دي او اي حاجه لو اعتبرنا 1. فدي this represent ال 1. يبقى this two signal elements وthis الباك is for amplitude. طب what about the final okay الاول how many points will draw 2 برضه. okay الامبليتيود fixed. نفترض طب الفيز الفيرست بوينت في الباينري كان عندي 0 1 كان ال 1 في الثird 0 وكان الزيرو 100. أو على فكرة وكان يعني لسه احنا راسمينه ال L equal to 4. كان عندي 4 بوينتس كلهم same amplitude يعني كلهم هيبقوا على circle but one width is 45 one width is 125 minus 125 minus 45. فده كيو. طب ال F scale ال F scale لما غير الفيز وغير الامبليتيود فعندي fixed amplitude وfixed phase فالاثنين هيبقوا كلهم على بعض لان same amplitude same phase. Okay. So this amplitude shift key we have two binary amplitude key, so we have 2 points, one with amplitude 0 and one with amplitude 1, with both of them on the positive x-axis and in phase 0. For the binary phase shift key, we have 2 points with fixed amplitude, with the same amplitude, but one with phase 0 and the other one with phase 100. 100. Okay? The cube is K, same amplitude, but different 4 phase. Okay? Is it easy to plot this figure? Okay. الكوان بقى موديليشن. الكوان موديليشن هو الجنرال كيس من الباينري فيشت كي الكيو بي اس الكيو بي اس كي. لا I will- so now amplitude and phase. So instead of have circle, لا now I can have a different one. One here, one here, one here. This amplitude can be different. And if one we can have بقى multiple zone. يعني now I'm controlling the amplitude كمان صح؟ يعني ممكن الفور zone for the same phase ممكن اعمل كمان another four صح؟ ايه الفرق بقى في الكنترول؟ ده same phase but different amplitude. فكان بقى same length وsame amplitude same phase but different amplitude. وهنا different amplitude وهنا different amplitude. ففي this case ونيجي ال كوام ال ده هو number of levels. ففور example if cube escape can be a special case from كوام and a special case for كوام. And we have four levels. So it can but with different amplitude. We can change the amplitude now. فinstead of circle it will be square. And we can have this amplitude different from this amplitude. And we can also change the phase. فخلينا مثلا نقول on phase 0 your phase 90 be on 44 45. فنحن controlling بقى الphase والamplitude. So I have and different shapes according to phase والamplitude. So in equam it's a general case combination of الامبليتيود شيفت كي مع الفيز شيفت كي. والمينيمم باندويث بقى ريكوايرد فور equam هي السيم باندويث فور اي اس كي and بي اس كي لان في الاخر I'm using the same carrier frequency but I'm changing both the amplitude and the phase. Different shape for equam again this is my SK. This is for the same frequency and this but different amplitude and this is on different phase. Different phase and different amplitude. So I can do it as I want. Also, I can have 16 coil. So L equal 16. So now I can, how many bits I can send at the same time? And R equal to what? For 16 coil. أو 16 coil يعني ال L equal 16 يبقى ال R ال L هي 2 to the power R 2 to the power M وال M هي number of bits inside the element. Well, this is one element. All these bits are sitting constant in one element. So R equal to 4 يعني لو R equal to 4 يبقى I have 16 variable 16 يعني level 16 level but R equal to 4 and now we have 16 combination in the same signal element. So I have 16 point. Each point is represented by a certain phase and certain amplitude. Okay, but this is a general case for 4 quad. Right. Is it easy to plot this figure؟ يعني السؤال ده جاله في الميد ترم السنه اللي فاتت نص الدفعه ما حلتوش مع انه في نص سلايد. What's better؟ سيم؟ لا هو السيم فور كوان سي الامبليتيود لما بيبقى صغير وحش ولا حلو؟ كونسيدر على طول التشانل انت الكلام this will transmit by transmitted in this shape or in this shape. هو المين ديفرنس ايه؟ ان الامبليتيود ديفرنس small هنا الديفرنس الامبليتيود And if we increase the distance between the symbols on the constellation diagram, it means better bit error rates. Because I increase the distance so I can decode it correctly. But on the opposite, I will increase the bandwidth. Then here I am sending are equal to 4. So I'm sending 4 bits at the same time. Here I'm sending 2 bits at this point of view. Send 4 bits at the same time. Okay? So this is the question. Which constellation diagram should have better performance? Mean? Why? More level. But what is advantage? سمول. طب السمول ايه مشكلته؟ هو السؤال ده بالظبط كان في الميد ترم عليه درجتين، درجه عشان تقول الادفانتج ودرجه عشان تقول الديس ادفانتج. لان ده بيتر، بس بيتر من انهي وجهه نظر؟ better from the bandwidth point of view ان انا I sent 4 bit at the same time but worse from the bit error rate لان السبيسز واحد اقل. That's better from bandwidth but worse from the bit error rate. This is better than worse. Okay. مع طبعا كان مطلوب الرسمه دي والرسمه دي. Okay. So we can stop here. Thank you.